If you open up your laptop and start browsing, you are interacting with a highly curated digital landscape. It is a familiar world built around search engines, social media platforms, and easily accessible websites. This 3D representation shows the scale of data across the entire internet. That tiny 5% sliver at the top is the surface web. It contains every piece of indexed information you can find using a standard search engine. Drop below that, and we find the other 95%. This is the deep web. It is completely unindexed, meaning search engines cannot crawl it. But it consists mostly of everyday, mundane data, things like password-protected medical records, corporate portals, and private legal documents. The vast majority of this unseen space has no sinister purpose. It is simply the administrative architecture of the internet, safely partitioned away from public view. Yet, tucked away within that massive repository of administrative data is a specific, highly obscured fraction known as the dark web. This small corner is engineered specifically to prevent discovery and tracking. This hidden architecture serves a critical legitimate function. Journalists reporting on corruption, whistleblowers exposing fraud, and political activists operating under oppressive regimes rely on this network. It provides them with life-saving anonymity. However, an environment where traffic cannot be traced naturally attracts a different demographic. Hackers use these same obscured channels to trade stolen credentials, exchange new malware strains, and run illicit contraband marketplaces. The exact same technical infrastructure required to protect human rights also serves as a secure harbor for the internet's most severe criminal threats. To understand how this hidden space operates, we have to look back to 1995, inside the U.S. Department of Defense. The military initially developed this technology to secure intelligence communications. Eventually, they handed it over to the Electronic Frontier Foundation, an organization dedicated to digital privacy, which transformed it into an open-source project called Tor. Tor solves a specific networking problem, moving your data from point A to point B without any middleman, or even the final destination, knowing the complete path you took. This network map illustrates how Tor accomplishes this. When you send a request, your data gets wrapped in encryption layers and arrives at the entry node. The packet then jumps through middle nodes. At each server, one layer is peeled away, revealing the next hop. Finally, the data reaches the exit node. It sheds its last layer of encryption before jumping to the destination server. But the moment traffic leaves that final Tor server, it is completely unencrypted. It sits entirely exposed for anyone monitoring that specific exit point. Because no single server ever holds the full map, true digital anonymity is achieved by enforcing structural ignorance at every step of the journey. That constant cycle of encrypting and decrypting across random global servers also demands a massive operational cost. It forces your internet connection speed to an absolute crawl. Because you are navigating an entirely ungoverned space, the servers you bounce between could be compromised. The environment is heavily seeded with pervasive malware and untraceable phishing traps. Tor can successfully hide the path you took, but it entirely removes the safety of the destination. Navigating this network is inherently perilous. Because of these architectural risks, simply downloading Tor is not enough to keep a user safe. Operating in this space requires extreme, layered countermeasures. The primary defense mechanism required is what cybersecurity experts call a security sandbox. A sandbox physically or virtually quarantines the Tor browser into a tightly restricted area of the computer. If a user accidentally downloads hidden malware, the malicious code is trapped inside the sandbox, preventing it from infecting the core operating system. Beyond that, users must employ a strict belt and suspenders strategy. They route their Tor connection through an end-to-end virtual private network to encrypt their exit traffic, while locking their machine behind a rigorous local firewall. When you build an architecture entirely around absolute privacy, you strip away the standard safety nets of the web. Surviving in that environment requires treating every single digital interaction as an active, hostile breach. Ultimately, the dark web possesses no inherent morality. It is entirely agnostic, a tool defined strictly by the actions of the people logging onto it. For the average user, the severe legal liabilities and overwhelming security threats make this space completely unfit to visit. Yet, cybersecurity researchers actively monitor these unindexed marketplaces every day. They track the sale of stolen credentials, dissect new malware strains, and map out global attack trends before they can strike the broader public. This digital Wild West is far too dangerous for a casual visit, but observing its shadows is precisely how security experts protect the 5% of the internet we rely on every single day.